Everybody, welcome to my channel. Today we have an amazing problem for you guys, right? So it's called find first and last position of element in sorted array, right? So let's quickly go ahead and read the problem statement, right? See what it's all about. So it says given an array of integer nums, right? Sorted in non-decreasing order, find the starting and the ending position of a given target value, right? So if the target is not found in the array, right, return those -1, right? To signify that it's not, it hasn't been found, right? We must write the algorithm, right, in log of n, right, time complexity, right? So very, very simple problem statement, right? So just to recap everything, right, they're saying that we're giving an array nums, right? We're giving this array nums, right? And we're giving a target as well. We need to find the starting and ending position of this value, right? So the starting value would be this piece of data, right? And then the ending value would be this piece of data, right? And that's why if we don't end up finding that target, right, we can just return -1, right, to signify that it's not in there, right? But we need to do it in log of n, right? So they're making it interesting for us, right? So very, very good. So let's go through an example to further solidify the concept, right? So we're looking for the target 8, right? And we need to find the beginning position, right, when it first occurred, and the last position where it occurred, right? So that's what they mean by the range, right? By giving them these two pieces of data, right? So we see that the first occurrence is index 3, right? And then the last occurrence of that number is at index 4, right? And that's why we end up returning those two pieces of data that they asked for, right? So this one is very important as well, right? So we're looking for 6, right? But 6 is not present in the array, right? So it's why we end up returning -1, right? So very, very good so far. And then this one's an empty one, and then we return -1, -1, right? So we could see this is very good so far. All right. So now we kind of understand everything, right? What's kind of the approaches that we can have for this problem, right? How do we tackle this problem, right? Like you guys already know, I always love starting with just a brute force solution, right? Non-clever way, just intuitive, just straightforward way, just trying to get the brain juices going, right? So so we're looking for 8, right? So how do we do it? So my intuition is telling me, right, I could do a linear loop, right? Hear me out. Do a linear loop, right? We find the first occurrence of that number, right? And then we store it, right? We note it down somewhere. And then we keep going, right? Up until we last see the number, right? And then as soon as we last, the last index we see that number at, right? We note that as well, right? And then we return this one, right? And just like that will be good, right? No, all right. This would be all right, but they want us to write it in log of n, right? And we know that its time complexity is of n, right? Because we potentially have to loop through the whole array, right, to find whatever number that we're looking for, right? So it doesn't, it's not very good. We need to do a little bit better, right? How do we do better though, right? Could we let me see. Let's see what's going on in the problem, right? So it says the array is sorted. Okay, and it says also the time complexity needs to be a log of n, right? So that they're kind of nudging, giving us hints to use binary search, guys, right? So array sorted, the first thing that comes to mind is always binary search. Okay, but how can binary search help me find, right? So I know binary search can help me find a number, right? A number target number, right? Pretty easily, right? I could find that, right? Okay, that can help me that. But okay, so can I just apply binary search and I find 1, 8, and then I return it? No, I need to find the beginning and the ending indices of that particular target, right? Okay, can I apply binary search? Okay, maybe we could do binary search, find that number, right? And then, right, find whatever number, right? And then, have 2 pointers, right? One that's going to on the left side and one that's going on the right side, right? And we just keep going to the left, go to the right, right? And then do the same thing, a linear loop, trying to find the beginning, the beginning boundary, and then one other loop that's trying to find the ending boundary, right? And then we know those 2 pieces of data we turn it, right? But it would not be good as well, guys, right? we need to do a log of n, right? You know, the loop is gonna mess us up, right? And even though we end up finding it, we're gonna need to do a linear loop to find the beginning and ending boundary, right? Which is not good. How can we improve though? Okay, maybe I'm thinking we could do a modified binary search, right? Okay, because we know what binary search kind of helps us with to discard the array in half every time, right? Cutting down the search space at every iteration, right? You know, it makes the searching a lot more efficient without having to search the whole array, right? Because imagine the array is huge, right? Those examples given, they're making it simple for us so that we can understand it and kind of keep it small, right? Imagine you have like a really huge array, a lot of numbers, right? You would see the advantage of you really using the binary search to solve this, right? So that's why binary search is going to be useful for this problem, right? Given that the input data given to us is sorted, right? And we can apply binary search, okay? So how can we do it, right? So I'm thinking, so when do we go left? When do we go right, right? So we know that we go to the right, right? When the middle element, right, that we're at, right? The middle element is less than the target, right? Then we go to the right because that's where all the bigger numbers are going to reside, right? So my target can have potentially be there, right? If it's going to be there, if it's going to be somewhere, that's where it's going to be. It's not going to be to my left side where all the numbers are smaller than I am, right? So we know what binary search is, right? Just like if the number, the middle element is bigger, right? I don't need to worry about my right side. I'm gonna go to my left side because that's where all the smaller numbers are at, and that's where I need to focus my energy, right? So this is like that. We can cut down the array in half every time, right? So how is it gonna help us, right? So we need to find two things, right? We need to find, so we're gonna kind of break it down a little bit, right? So the first problem that we're gonna find, right? We're gonna do it in ways that we need to find the beginning index of that particular target, right? So essentially the first occurrence of that, right? So we're gonna apply a binary search to find that, right? And then we're gonna do another binary search to find the ending boundary, right? For that particular target, right? So we're gonna optimize, we're gonna modify the binary search the regular way of the binary search, right? For both of those two problems, right? And then once we solve those two problems, we can return our answer, right? All right, first let's start talking about how do we find the beginning index of the particular target, right? Okay, so we know that we do regular binary search, right? So let's say right now we're focusing on finding the beginning index, right? So we know we go to the left, right? Where when a number, right? I told you guys when a number is bigger, right? The middle element is bigger. I focus my energy on the left side, right? Okay. But if we're trying to find the beginning index of the target, right? We're not only going to go to the left, right? When an element is bigger, right? We're also going to be going to the left if that element also equals to the target, right? I'm gonna keep going to the left because I'm trying to find the leftmost index of the target element, right? So, but as I'm going to the left, right, if the middle element equals to the target, I'm gonna note that down, right? So this is the last time I saw this number, right? So I'm always going to keep track of the last time I said number, right? So if we're trying to find the first occurrence, right, we go to the left whenever a number is bigger or equal to it. I keep going to the left, right? And if a number is, smaller, we go to the right. That's the only time we go into the right, right? If it's smaller, right? But when we're trying to find the other index, right, which is the ending index, right? We're gonna go to the right, right? We normally go to the right when we have to. We go to the right when we have to. When a number is smaller, right? We go to the right, right? But also we're gonna go to the right if it's equal, right? Because we're trying to find the rightmost number, right? Index of the target element, right? So how else is going to be at play here, right? So we see index 0, 1, 2, 3, 4, 5. We do 5 divided by 2 gives us index 2, right? And then we check, guys, where we're going to x, right? So let's say we're trying to find we're trying to find the starting index of 8, right? So we check, is 7, is it less than the target? It's less than the target, right? So that's why I'm going to go to the right. So I focus my energy there, right? So that's where the number is going to be at, right? And then I do the same thing, guys, right? We do binary search. We see 8, right? Is 8 a less than? It's not less than, right? So we know that 8 must be greater or equal, right? So we know we go to the left, right? So now the boundary becomes here, right? And then we apply binary search, you see that number, we exit out. And we also, every time so the last middle element, right, for this subarray, right, will be 8, right? We store that info, and then we return that info, right, to index 3, right? Okay. And likewise, guys, right, we're gonna find index, so let's say now we're trying to find the rightmost boundary, right? We apply the same logic, guys, right? We see that 7 is less than, right? It's less than, then go to the right. Okay. Then we apply another binary search. We see that the middle element is this, right? And then we keep going to the right, right? Because the value of the middle element is I told you guys we go to the right when we're trying to find the any boundary, right? We go to the right if the value at the middle element is less than or equal to the target, right? And then we go to the right, and then we every time we go, right, I'm telling you guys we're noting down the last occurrence we saw that target number at, right? And then we end up returning that 4, right? You know, that's how we make it efficient in our search, right? And applying binary search to find the beginning index and the ending index, okay? So that's kind of the main point, right? So let's quickly go into the code, right? Hopefully you guys were able to find it, right? And able to understand the thought process and things like that, right? So let's quickly go into the code, okay? Let me know in the comment section as well if everything makes sense, right? So we're gonna store the results in an array, right? Because we need to return that. I meant to put 2. Okay, so what's gonna be next? Make sure I a space for you guys to see. We're gonna do res of 0, right? So that's gonna store our beginning index, and then we're gonna have another thing that's gonna help us in getting the ending boundary, right? So we need to find the beginning boundary and then the ending boundary, right? So we're gonna be writing those things right there, and once we do that, we're gonna return this array, right? That's containing those 2 pieces of data, right? That we want. And it's we call it helper. We call it find start. Okay, just copy that. Looks good so far. So now we're gonna have. So I told you guys we're gonna be noting down every time. We're gonna be noting down the index, right, of the last time we've seen that number, right? And we know how to write binary search. You know, we have a lot of different problems this channel. So initially we considered the whole. Array initially, right? And we do on the left, the left, there we go to the right. We calculate the midpoint. This is just doing it to avoid integer overflow, right? What else do we need? We're gonna check. We know we're gonna be doing to check here, right? So we said that now we're trying to find the starting, right, boundary, okay? So we're gonna check if the middle element, right, is greater than, right? Then we go to the left, right? But also if it's equal as well, we keep going to the left, okay? Targets, okay? So we go to the left by updating the index, right? And then we got the left boundary that goes if it's less than, right? We need to go for like up, right? Go to the right side. And after we do that, we're gonna return the index, right? So since I'm gonna be returning the index, right? I could, start this off with -1, right? So if we don't find that number, right, in the array, we return -1, which will be stored here, right? We should take care of this. So we also need to, let's do a check here, right? Every time, I told you guys we're gonna be noting down the last time we saw that element or the target element, right? So we're gonna be updating, right? So it equals the target. We're gonna be updating the index, right? So it could have been, right? So this is the last time I saw it. I note it down, and then once I'm done with this while loop, the last index, right? For this one will be the beginning index, right? Or when the range of that number, okay? So now we're gonna be doing the same thing, right? We could have used this same method, right? But to keep it clean, we're gonna use a separate method, right? So same thing, guys, right? So now their logic kind of reverses, right? So now uh if the value, right? So now I'm trying to get the last index of the element, right? So if the value is less than, right? I have to go to the right anyway, right? If it's less than, but now if it's also equal, right? I keep going to the right because I'm trying to find the right most, right? Just make sure you guys we understand that concept, right? Okay, looks good to me. Right. So let's yeah. So that's what we kind of do, guys. Right. So let's press run code. Looks good so far. You could have had a check, right? Just here to add if it's -1, just return -1, right? You could have done that, but it's good. It should be fine. So let me know if you guys find value in this particular problem, right? If it makes sense to you guys, right? If you guys understood everything, let me know in the comment section. And yeah, I'll see you guys in the next video.